Okay, so today we're going to have a look at the shortest distance from a point to a line. All right, so we'll start off with a bit of a statement. So we've got so the shortest distance from a point to a line is perpendicular to the line. All right, what does that mean? So if I've got a line, oops, just imagine that's a straight line. Pen just dropped out there for a second. A line, and we're going to call that vector B. All right, and it's going that way. And I've got any point. I could put it anywhere, but I'll put it here. All right, I'm going to call that point P. So what this statement says is if we have a point P and a line, the shortest way we get there is by drawing a line directly perpendicular to that. Now, the proof is just a little bit of Pythagoras. So if we drew any other line, like if I drew a line from there to there, you might think that's a bit shorter. What we've got is a right angled triangle, and that's the hypotenuse. And the hypotenuse is always the longest side. So this is always shorter this way. So the only way you can do this any shorter than this line is by moving it closer to this length, the perpendicular line, and the closest will be on the perpendicular line. All right. So I'm going to do one more thing, and I'm going to label this point R. All right. So this actually allows us a really interesting little fact here. So because the perpendicular line is the closest, we know that the dot product of two vectors that are perpendicular equals 0. So if I drew a line from P to R, we'll call it PR. That's going this way. All right, that's a vector. And I've got my vector B going that way. If I did the dot product of those two, because they're perpendicular, it's going to equal 0, and that's going to allow us to work out a lot of really neat things. So let's have a look at an example. We're going to consider the point -1, 2, 3, and the line with parametric equations x equals 1 plus 2t, y equals -4 plus 3t, and z equals 3 plus t, where t belongs to the real numbers. We've first been asked to find the coordinates of the foot of the perpendicular from P to the line. All right, so we're going to start off by saying the velocity vector of the parametric equations is always equal to the numbers in front of the t. All right, so that's going to be 2, 3, 1. So we can say that we'll call it B. Equals 2, 3, 1 is the direction vector. Just again, where we got that from is our x had a 2 in front of the t, so we put 2 in the x, 3 for the y, and z had a 1. So let's call the line that we're moving on, let's call that A. So let A be equal to 1 plus 2t, -4 plus 3t, and 3 plus t. So all of those coordinates are described in this parametric equation. I'll just put it into this form. And what we're going to do is, again, let's just draw a little summary. So that there, we're going to call that our line A. And we have a point P. So this might not be to scale, but it's close enough for now. And our direction vector B, the length of B is going that way. Okay, and we want to find the position here, R, of the foot of that vector. So firstly we need to work out our vector PR. All right, so PR is equal to our R value, which is this here. We don't know the time yet, but we're going to work that out. So 1 plus 2t, subtract whatever our P was. So our P, remember, was -1, 2, 3. That was given in the question. So -1 plus 2t, take away -1. The next one will be -4 plus 3t, take away 2, and 3 plus t, take away 3, which equals 2 negatives becomes a plus, so 2 plus 2t, negative 6 plus 3t, and 0 plus t. So just t for that last point. So what we're going to get is, if these things are perpendicular, we're going to get our PR is perpendicular, I don't know what happened there, perpendicular to our vector A, and hence our vector PR, if we did the dot product of that with our direction vector B, we're going to get that equals to 0. All right, so let's have a go at that now. So our PR is this one here, so 2 plus 2t, negative 6 plus 3t, and just t at the bottom. If we take the dot product of B, our B is 2, 3, 1, that's the direction vector it's moving. We're going to get, this thing's going to equal 0, but let's expand it first. So dot product, you do the first row times the first row. So it's going to be 4 plus 4t plus second by second, negative 18 plus 9t. And our last one is just going to be plus t. We're going to get a total, if we just sum them all up, we're going to get 4 plus negative 18 is negative 14. And 4 plus 9 plus, so we're going to get plus 14t. So because this thing's equal to 0, we can bring the 14 to the other side. So 14t equals 0, equals 14, and t equals 1. So this thing is going to equal the base of the coordinates is going to happen when t equals 1. So we can put that back into our, we can put it into either equation. We can put it into this one or our original. So I'm going to put it into our original one. So our x was 1 plus 2t. If t is 1, it's going to be 1 plus 2, so that's 3. Negative 4 plus 3 is negative 1, and 3 plus 1 is 4. So this is the coordinate of the foot. So I've just run out of room, but I would write a little sentence to say that. Yeah. So hopefully we've got a couple of skills now that we could go and use on some problems. Thank you.